lecture, we continue our discussion about lists and learn about a new data structure called dictionaries. Let's go over a couple of review quizzes. Assume that the variable data refers to the list which has 3 items, 10, 20, and 30. The expression data 1 through 3 evaluates to which option? So we know that in a list, data is organized by its position. So it automatically assigns a position to each item. By default, the position of the first item is 0, the next one is 1, the following is 2. So 1 through 3 evaluates to 20 and 30. In this list, we don't have any item in position 3, so the answer would be 20 and 30, option B. For the same variable, data, after the statement data 1 equal to 5, data evaluates to which option? So we also learned that we can update values in a list if we identify their position. So here the position is 1. So it means that it's related to the second item in the list. Now we replace the second item with 5. So the right answer is 10, 5, 30, option B. So in this lecture, we want to learn about searching and sorting a list. Also, we want to discuss a new data structure called dictionaries. So we learn how to construct dictionaries and access entries in those dictionaries, how we can manipulate their values. And we go over some methods which help us with manipulations and updating the value in dictionaries. If you remember, the in operator determines an element's presence or absence in a list, but it doesn't return the position of that element if found. So if we want to know the position of that element in a list, we need to use another method called index, which locates an element's position. When the target element is not found in the list, it throws an error. So here's an example. We have a list named A list, which has 3 items, 3 numbers. Let's say the target value is 45. If target in a list, so we are defining a conditional statement, and if that target is in the list, we want to print its position. So we print alist.index target. So the index method returns the position of the target value. Otherwise, we print -1. It means that we couldn't find that target value in the list. Let's try and implement this. A list equal to 34, 45, 67. Target is a variable which contains 45. Now, if target in a list, print alist.index, so return the index of the target value. Else, print -1. Okay, let's run this. So the result is 1. It means that the target value is in the list, okay, and its position is 1. So if you look at our list, the position of the first item is 0, the second one is 1. So 45 is in the first position. Okay. Let's change the target, for example, 66. If you run this, then we will see -1. It means that this value doesn't exist in the list. Now sorting a list. We know that list is a sequence of items, numbers, or a string, or even the combination. A list elements are always ordered by position. The position or an index is assigned to all items, but you can impose a natural ordering on them. For example, you want to sort them in alphabetical order. When the elements can be related by comparing them, greater than, less than, or equal, they can be sorted as well. The method sort mutates a list by arranging its element in ascending order. So this is one of the built-in functions. When we apply sort to a list, then it sorts all the elements in the list in ascending order. So here is an example. We have a list with 4 items, and then we call that variable, apply sort method, and we print it. Then you can see that all items are sorted in ascending order. Now let's try to implement this quickly. So example, this list 4, 2, 10, 8. I call a variable, apply the sort method, and now we print it. So you can see that all the items are sorted, and the smallest one in the first position, the largest one in the last position. The index for the first position is 0, next one is 1, 2, 3. Okay. Now a note. All of the functions and methods examined in previous chapters return a value that the caller can use to complete its work. So it means that we receive the value and then we can apply other procedures to calculate other things. Mutator methods like insert, append, extend, pop, and sort usually return no value of interest to caller. Python automatically returns the special value none. It means that if we apply the sort method to a list and then we print it, then it automatically returns none. So let's try implement this and quickly see that none value. So a list refers to this variable. We apply sort and then we print a list. You can, let me assign it to a new variable. And now you see the none value. Okay. We first sort it, we update the variable, and then we print the variable, it returns none. Now here's an exercise for you to wrap up our discussion about list. Here we want to use a list to find the median value. So a median value divides the data into half. So we want to find that middle point. Let's assume that we have a sequence of numbers, because it's a sequence of numbers, so we can use list as a data structure, and we can calculate the median. The first step to calculate median is to sort the data in ascending order. So we sort the data, and then we count the number of items in that list. If it is an odd number, then we find the middle value, the position of the middle point, and that would be our median. If the number of items is an even number, then we find the 2 numbers in the middle, and then we take an average. So let's try to use the methods that we have learned for list and write a program that calculates the median value. So first, you sort the items in your list, and then you have a selection statement. Using the len function, you can count the number of items in the list, and then if it is an odd number, then you calculate the median value, and if it is an even number, you calculate the median value. So you take the average or just find the position of the middle point. So we will discuss this in one of our live sessions, but it's a good practice. It kind of summarizes the main point that we have discussed so far. And here I would like to bring up another point, that when you want to start writing a code, always don't rush to implementation. Try to write pseudocodes. Try to write the logic first. Okay, using English words. In the first step, we sort the numbers in this example. In the second step, we count the number of items, and based on this condition, we decide how to calculate the median value. So it's always a good practice to have a plan, to write down our logics, and then try to implement the codes. Okay, so with this, we wrap up our discussion about the list and start learning about a new data structure called dictionary. Okay, a dictionary organizes information by association, not position. In list, we had a sequence of items, and for each item, we had an index, a position. But for dictionary, we organize information by association. Here is an example which explains it better. So when you use a dictionary, an English dictionary, to look up the definition of mammal, you don't start at page 1. Instead, you turn to the words beginning with M. So there are different categories, A through Z. And if you want to find mammals, you go to the category starting with M. It's the same story for dictionaries in Python. Data structures organized by association are also called tables or association lists. So we need a category, keys, and then some values. So in Python, a dictionary associates a set of keys with data values. So we can have different keys, and then under each key, we can have different values. Now let's learn about the syntax, how we can define dictionaries in Python. A Python dictionary is written as a sequence of key value pairs. So we need a pair, key and value, which are separated by comma. Pairs are sometimes called entries, and they are enclosed in curly braces. So if we want to use a dictionary as our data structure, we always use curly braces. For list, we had a square bracket. A colon separates a key and its value, and that's how we assign values to each key. So first we have the key, and then colon, then we assign a value to that key. So here you can see a few examples. A phone book. It's a dictionary, so you see the curly braces here. Savannah and their number. Nathaniel and their number. In the next line, you see personal information. It's again a dictionary with two keys. The first key is name and its value is Molly. The next key is age and its value is 18. And if you want to have an empty dictionary, then you have the empty curly braces. Keys in a dictionary can be data of any immutable types, including other data structure. So keys can be a string, can be integers, can be fractional values or float, but they are normally a strings or integer or a combination. Now let's see how we can add a new key and value pair to a dictionary using the square bracket. In this example, you see an empty dictionary info. Now we want to define a key and a new key and then assign a value to that key. So I call the variable info, then a square bracket, and then I have the key name equal to Sandy. Then Sandy is a value for that key. If we want to add another key, let's say occupation, so I use a square bracket equal hacker. Now hacker is the value for occupation. And if we print it, you will see this dictionary. We use the square bracket to replace a value at an existing key. Let's say we want to update the value. So we call our variable and then the key occupation, assign the new value to that key. So info occupation is equal to manager. Now the new value for occupation is manager. So hacker is replaced by the manager. So let's quickly implement this. Info, first an empty dictionary. Now I want to add a new key. We use a square bracket, name equal to Sandy, and it's a string. I define another key, occupation, and it's equal to hacker. Then we want to print it. Let's run this. Okay, now you will see a dictionary. Curly braces, name is the first key, its value is Sandy. Occupation in the second key, and its value is hacker. Now let's say we want to update the value. So I call my variable and then its key, occupation. Now I assign the new value, which is the manager. And then I want to see the updated variable. Now here we have the same keys, name and occupation, but the value for the second key is updated. Now it's a manager. How we can access values in dictionaries? Again, we use the square bracket to obtain the value associated with the key. If key isn't present in dictionary, an error is raised. Okay, so info name, we do have a key called name. Then its value is Sandy. But let's say if we call info job, we haven't defined this as a key. Then you will see this error. And in the next line over here, you see if name in info, we want to check if this key exists in this dictionary. Print its value. So let's try to implement this. Info name. Okay, then you see its value. The value for this key is Sandy. And now let's try to call a key which doesn't exist, like job. And then you see this error, key error job. Let's write a conditional statement. If name in info colon print info name, print its value. Okay, we run this, then you see, okay, the result is Sandy. So name is in this dictionary, info, and then its value is Sandy. Okay, now we want to go over some methods just to manipulate a dictionary, very similar to list. For example, if we want to remove a key, we use pop. To delete an entry from a dictionary, remove its key using the method pop. Pop expects a key and an optional default values as argument, so it's optional. But here, we want to say, okay, info.pop occupation. It means that drop that key, which is name occupation. And then you print the updated variable, then you only see one key, which is name. See what it looks like in Python notebook. Print info.pop this key, occupation. you run it, then it shows its value. It is dropped, and let's look at the updated variable. Now, info is a dictionary with one key and one value. So that's how we remove a key. We can also traverse a dictionary, going through all keys and their values. So in this slide, you see a few examples. To print all of the keys and their values, we can write a for loop because we want to go through all keys and their variables. So that's why we use the for loop. Now, here you can see for key in info, print key and its value. So let's implement this. For key, after for, we expect a variable in info colon print key. We want to see the key and its value. Info key. Then you will see name and Sandy. So the key is name, its value is Sandy. There are other examples here. We can use a method called items. So in this example, we have a dictionary with 3 keys, and keys are numbers. So 90 here is a number and its value is a string A. The second key is 80 and its value is B. And the third key is 70 and its value is C. Now, if we use the items, so we call the variable dot items, and we want to see them as a list. If you remember, we can use the list method to make everything a list. So we expect to see a square bracket because now it's a list, and also the pair of keys and their values. So let's implement this. So we have a new dictionary called grades. So we will see curly braces. 90, its value is A. 80 colon B. And then 70 colon C. Now I apply list and pay attention to colors. It is a reserved word, so its color is green. I call my dictionary grades, then I apply items. And when we run it, you see a list, and each item presents the pair of key and its value. So this list has 3 items, and each item shows the key and value in our dictionary. In the third example here, entries are represented as tuples within the list. For key and value in grades items, because we know that the result of grade items is a pair of key and value, and then we can print it. We write a for loop for the pair of key and value in grades dot item print key and value. Now you can see the value, the key and their value. So this is another way to print the pair of key and values in a dictionary. Okay. We can also sort the list first, then traverse it to print the entries of dictionary in alphabetical order. So here we define a variable. Its data structure is list because we are applying the list method here, and then infos.keys. When it is a list, then we can apply the sort method, and then we will see that in alphabetical order. And then for key, after the for loop, we expect a variable in the key, which is our list, print the key and its value. So let's try to implement this. I define a variable, I call it the keys. You can go with any other names. It's a list, info.keys. So let's run this. Okay. And let's sort it. The keys. So we already dropped the one of the we applied pop to occupation. Let me update info. Now it has two keys. So the keys dot sort, and then I write a for loop to go through keys and their values. So for key in the keys, print key and info dot key. Okay, we don't need the dot part. Okay, name and Sandy. Okay, let me define a new info to make sure that we have two keys. Okay, now name and occupation, we sorted, and now you can see that the alphabetical order: name first, occupation second. Now let's say this, what happens if we change this variable? Let's say I go with I. Then we run it. So I get the same result. I just wanted to show that key is just an arbitrary variable. You can go with anything. So it's not a reserved word in Python. Okay. So far we learned how we can update values, how we can traverse a dictionary, how we can drop a key and their values. And in this table, you can see many useful operators that you can apply to your dictionary. Still, you can apply len function, which returns the number of entries in your dictionary, named d. D square bracket and key is used for inserting a new key, as you saw a few examples before, replacing a value or obtaining a value at an existing key. You can also use the get method, which returns the value if the key exists, or returns the default if the key doesn't exist. We had an example for using a pop, which removes the key and returns the value if the key exists. If you apply list, it returns a list of the keys. And also you can apply the for loop here. Key is bound to each key in the dictionary in an unspecified order. Okay. Now I would like to wrap up our discussion about list and dictionary with this example. It's important to identify when we can organize our data in a list and when we can organize it in a dictionary. So we want to determine whether a list or a dictionary is an appropriate data structure for a given application. Here you can see a table. So we know that for list, we organize the data by their position. So we have a sequence of items. And then for dictionary, we have a table. We organize by association. We assign keys and then values. So in this table, we can extract 3 pieces of information when we look at this table. We know that, okay, we have 3 customers here. We also see that there are 3 suppliers. There are values in the table. For example, from customer 1 to supplier 1, 100 miles. So it shows the distance from customer 1 location to supplier 1 location. And we have this information for each pair of customer and supplier. So technically, 3 pieces of information. Now I would like to discuss when we use the dictionary, when we use the list. We just want to summarize the information and translate it into list and dictionary. Okay. So for the first piece of information, customers, we have a sequence of items, customer 1, customer 2, customer 3. So in this case, list is an appropriate data structure. The same story for suppliers. I have a sequence of items. So I know that I have 3 suppliers. So I can use a list to organize this data. And then I have distances between each pair of customer and supplier. And you will see the table. So it means that I can define a key and then assign a value. So the first key can be the pair of customer 1 and supplier 1. And then I assign 100, which shows the distance. The other key can be customer 1 and supplier 2. And then its value is 50 miles. So that's how we use dictionary to save information here. And here's the list and dictionaries I was referring to. So customers is a variable and its data structure is a list. So you see the square bracket and it has 3 items, C1, C2, C3, representing customers. For suppliers, again, you see the square bracket and it's a list which has 3 items, supplier 1, supplier 2, and supplier 3. Now I define a new variable named distance and it's a dictionary. So you see curly braces here. So when we use a dictionary, we need to define keys and their values. So the first key is the pair of customer and supplier. I use colon, then I assign the distance in miles to that key. So the key can be a single item. It can be a pair of items, like this example. In other application, you can add third item. So C1 is to time 1. Then your key has 3 items, and then you use colon to assign values. In some applications, your dictionary can have 1 item for the key. For example, just C1. So that's how we save the information, different pieces of information we have from the table using list and dictionary. And you are going to see this format in linear optimization that we are going to discuss at the very end using GrowBPy library in Python. Now to summarize, a dictionary associates a set of keys with values. A square bracket is used to add a new key or value pair to a dictionary or to replace a value associated with an existing key. Dict type includes method to access and remove data in a dictionary. So it's very similar to list. When we apply dict to everything, then it becomes a dictionary. And then we can access and remove data in a dictionary. So with that, we wrap up our discussion about list and dictionary as a data structure.